Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is section 11.5, alternating series and absolute convergence. We will talk about this video about alternating series test. The convergence tests that we have looked at so far apply only to series with positive terms. If you remember, comparison tests only used for uh, series with positive terms and also integral test. So in this section and in the next one, we will learn how to deal with series with terms that are not necessarily positive. We will start by alternating series. Terms alternate in sign. So for example, this series positive, negative, or negative, positive. So we always have negative 1 to the power n minus 1 or to the power n. If n is 1, then the series starts here by negative sign. So if it starts by negative sign, we write it negative 1 to the power n. If it starts with positive sign, we write it with negative 1 to the power n minus 1 or n plus 1 also will work. So notice that we will differentiate between an, this is an, okay? What is inside the series? This is an, the nth term of this series, okay? And this is also an. And an always in the alternating series can be written as negative 1 to some power times bn. So what is bn here? It is 1 over n. What is bn here? It is n over n plus 1. Notice that bn is in fact the absolute value of an. When you take the absolute value of an, the absolute value of negative 1 would be positive, so you get bn. So bn has are positive, pn are positive terms. So you can apply what we learned in the previous sections about bn. What does the alternating series test says? It says that if there is an alternating series, okay, then if bn satisfies two conditions, if bn plus 1 is less than or equal to bn for all n, and this means that bn is decreasing, and if the limit of bn is 0, then the series is convergent. What series? Summation an, the alternating series. So if the terms on of an alternating series decreases toward 0 in absolute value. So these two conditions say decreases towards 0 in absolute value. Absolute value because we are dealing with Bn. Decreases because of this condition, towards 0 because of this condition. So now, when you have an alternating series, just consider Bn, prove that Bn is decreasing, find the limit of Bn. If it is 0 and Bn is decreasing, then the alternating series would be convergent. Let us consider this series, and we will call it the alternating harmonic series. You remember the harmonic series is summation 1 over n. So if we have negative 1 to some power, then this is the alternating harmonic series. It is an alternating series. So what is Bn in this case? Bn is absolute value of an, or it is just 1 over n. Now limit Bn when n goes to infinity is limit 1n when n goes to infinity and 1 over infinity is 0. So the first condition is satisfied. The second condition, 1 over n plus 1, this is bn plus 1, is what is the relation between 1 over n plus 1 and 1 over n? This is less than this because this is n plus 1 greater than n. So 1 over n plus 1 is less than 1 over n. So it is decreasing. Bn is decreasing for all n greater than or equal to 1. So it satisfies the two conditions. So by alternating series test, summation an converges, where this is an. So summation an converges. So the harmonic series is divergent, but the alternating harmonic series is convergent. Notice the difference. In the harmonic series, you are adding 1 plus half plus 1 over 3 plus infinite terms. But here, some of the terms are negative. 1 minus half, 1 over 3 minus 1 over 4. So this may be the reason why this infinite sum converges, but this infinite sum does not converge. So keep this information in your mind. Alternating harmonic series are convergent. Another question, another example. What is Bn here? It is 3n over 4n minus 1. Let us find the limit of Bn when n goes to infinity. How to find the limit of 3n over 4 minus n when n goes to infinity? We deal with terms with the highest power when n goes to infinity. So the answer is 3 over 4. This limit is 3 over 4. It is not 0. Okay. So it does not satisfy the conditions of the alternating series test. But what does it mean that the limit of Bn is 3 over 4? What would be the limit of An, which is negative 1 to the power n times Bn when n goes to infinity? Okay. It could be positive or negative. It could be positive or negative 3 over 4. So it oscillates between positive 3 over 4 and negative 3 over 4. So in fact, the limit does not exist. It does not approach a specific number. It oscillates between 3 over 4 and negative 3 over 4. So the limit of an does not exist. But if the limit of an does not exist, then by test for divergence, do you remember test for divergence? It says that if the limit of an is not 0 or does not exist, then summation an is divergent. So if for alternating series, you find that the limit of Bn is not 0, then you conclude that the limit of An does not exist. And by test for divergence, the series is divergent. What is Bn? This is an alternating series. What is Bn? It is n square over n cube plus 1. And if you want, you can always say also that 1 over n is greater than 0 for all n greater than or equal to 1. I mean, Bn is positive, has positive terms. Okay, so Bn is n square over n cube plus 1 and it's greater than 0 for all n greater than or equal to 1. Let us find limit Bn. When n approaches infinity, you take the highest powers, and this would be 1 over n. 1 over infinity is 0. So the limit of Bn is 0. Now, how to show that it is decreasing? I have n up and n down. So if you remember, we find the function. We write the function and find the derivative and prove that the derivative is negative when n is greater than or equal to 1 or any other number greater than 1. If the derivative is negative, the function is decreasing. It is not easy here to show that Bn plus 1 is less than Bn. So this is f of x. Let us find f prime of x using the quotient rule. Derivative of the numerator is 2x. Derivative of the denominator is 3x squared times x squared x to the power 4. So f prime is 2x minus 2 minus 3 is minus 1. If you take x as a common factor, 2 minus x cube over x cube plus 1 to the power 2. So this is f prime. Okay. Now we need to discuss where f prime is positive and where f prime is negative. And to do that, we need to find the zeros of f prime. Notice that the denominator is always positive, and the zero of the denominator is negative 1. But I'm interested when x is greater than or equal to 1, because n starts from 1. Also, x here has a 0. The 0 of x is 0, but I'm not interested in 0 also. So let me find the 0 of 2 minus x cube. Then x cube would be 2, or x would be cube root of 2. And cube root of 2 is about 1.3, approximately 1.3. So let me discuss the case when f of x is greater than 1.3. What would happen if x is greater than cube root of 2? F prime of x would be what? Take a number greater than or equal to 2, greater than 1.3. 10, for example. 2 minus 1000. This would be negative. This would be positive. This is positive. So f prime is in fact negative when x is greater than cube root of 2. This means f is decreasing. For x greater than cube root of 2. And this means Bn is decreasing for n greater than cube root of 2, or just let us say greater than or equal to 2, because n starts from 1, 2, 3. So Bn is decreasing for n greater than or equal to 2, and the limit of Bn is 0. So by alternating series test, summation An from 2 to infinity is convergent, and you can add If you add a term, there is no problem. This does not affect the convergence. So also series summation an from 1 to infinity converges, where this is an. So this is what you need to do to use the alternating series test. Some exercises. I have a series here, but I need to write it as summation, okay, to find an. So how to find an? You see that you have 2, 2, 2. You see first that you have positive, negative, positive, negative. So there is negative 1 to the power n minus 1 or n plus 1. If you put n 1, it would be positive. And now I have a fraction and I always have 2 in the numerator. But in the denominator, when n is 1, I have 3. When n is 2, I have 5. When n is 3, I have 7. So I am adding actually 2. I am adding 2 to each denominator. 3 plus 2, 5 plus 2. So if you are adding 2, then you immediately have 2n here. Okay? If you are adding 2, you will have 2n. 2n maybe plus or minus something. So let us find 2n plus or minus what? But you must have 2n. Put n1. If you put n1, I'll have 2. But the first term is not 2, it's a 3. So I need to put 2n plus 1. Now if n is 1, the first term would be 3. If n is 2, the second term would be 5, and so on. So if the difference is 2, you write 2n and then find out whether it's 2n or 2n plus 1 or 2n minus 1 or whatever. So this is the series he is talking about. And this is an alternating series. And let us consider Bn. What is the limit of Bn? Bn is 2 over 2n plus 1. When n goes to infinity, 2 over infinity is 0. And if you replace n by n plus 1, this is of course less than this one, because the denominator here is greater than the denominator here. So it is decreasing also, decreasing, and the limit is, and of course 2 over 2n plus 1 also is positive. Okay, so we can say here that Bn is 2n plus 1, and it's always greater than 0 for all n greater than or equal to 1. So by alternating series test, summation an is convergent, where this is an. Another series, negative, positive, negative. So there is negative 1 to the power n this time, because it starts by a negative sign. If n is 1, this would be negative. Now we have, what do we have in the numerator? 2, 4, 6, 8. I have 2 here, 2 to the power 2 times 2 here. Okay, here 2 times 3, here 2 times 4, here 2 times 5, here 2 times 1. So with 1, I have 2 times 1. With 2, I have 2 times 2. With n, I'll have what? 2 times n. Also, you can say that I am adding 2. 2 plus 2, 4 plus 2, 6. I am adding 2. So I must have 2n. Then replace n by 1, I have 2. So it is 2n without plus or minus anything. Here 5, 6, 7, 8, 9, you are adding 1. Adding 1, so it is n. 1n. Okay. But if you replace n by 1, I'll get 1, not 5. I need it to be 5, so I add 4. So if n is 1, I'll get 5. If n is 2, 2 plus 4, 6, 3, 7. So see the difference between the numbers. If it is 2, then you have 2n. If it is 1, you have n. So this is the series, and Bn in this case is 2n over n plus 4, and it is greater than 0 for all n greater than or equal to 1. Now if we find limit Bn when n goes to infinity, we will find that after taking the highest power here, the highest power here, that the limit is 2. 2 is not 0. You remember what happens when we find that the limit of Bn in an alternating series is not 0. Immediately we say that the limit of An, this is An, okay? This is An. The limit of An does not exist because it would be plus or minus 2. So by test for divergence, summation An diverges. Another series, I have length 3, 4, 5, 6. The numbers are increasing by 1. The first term is positive, so I have negative 1 to the power n minus 1. 1 over len n, because the difference is 1. But look to the first number. If n is 1, this would be 1, but it is 3, so n plus 2. If n is 2, it would be 4, and so on. So this is the series, and Bn is 1 over len n plus 2, and this is positive for n greater than or equal to 1, because len after 1 is positive. Now limit Bn, which is 1 over len n plus 2, when n goes to infinity, len infinity is infinity, 1 over infinity is 0, and 1 over len n plus 1 plus 2 is equal len n plus 3 is less than len n plus 2, because len n plus 3 is greater than len n plus 2, because len is increasing here. Len is increasing. So 1 over len would be decreasing for n greater than or equal to 1. So it satisfies the two conditions. So by alternating series test, summation An converges. So this series converges, and this is An. Well, here, what is Bn? It is 1 over 3 plus 5n. It's greater than 0 for all n greater than or equal to 1. Limit of Bn is 0 when n goes to infinity, because 1 over infinity is 0. 1 over 3 plus 5 times n plus 1 is less than 1 over 3 plus 5n, because the denominator here is greater than the denominator here. So Bn is decreasing. So by alternating series test, summation An converges. So this alternating series also converges. This is An. What is Bn here? It is easy to prove that it is decreasing and the limit is 0. So by alternating series test, this series also converges. While here Bn is 3n minus 1 over 2n plus 1, and limit of 3n minus 1 over 2n plus 1 when n goes to infinity is limit 3n over 2n. It's 3 over 2, not 0. So limit of an does not exist, and by test for divergence, summation an diverges. Notice that this is Bn and the limit would be 1. So the series would be divergent by the test for divergence, exactly similar to number 7. What is Bn here? It is e to the power negative n, or 1 over e to the power n. This is greater than 0, and limit Bn when n goes to infinity 1 over e to the power infinity is infinity, 1 over infinity is 0, and 1 over e to the power n plus 1 is less than 1 over e to the power n, because e to the power n plus 1 is greater than e to the power n because e is increasing, so 1 over e would be decreasing. So by alternating series test, summation an converges. So this is how we deal with alternating series. Also here, if you take this Bn, it is easy to prove that, well, the decreasing here needs the derivative. So let us find it. So this is Bn and it's greater than 0 for all n greater than 1, and the limit of n square over n cube plus 4 when n approaches infinity is the limit of n square over n cube, which is 1 over n, so it is 0. But to prove, it's not easy to prove decreasing here, so we need to write f of x and find its derivative. Please do the same as this exercise here. I did it for this function, this example, this one, okay? This is x squared over x cubed plus 1, and this is x squared plus x cubed plus 4. It's exactly similar. So please continue the question and prove that it is decreasing for some value of n greater than 1 or maybe 2, maybe something. And then by alternating series test, this series would be convergent. Well, here, what do we have? Bn is n over 2 to the power n. And that's greater than 0 because if n is 1, it would be 1 over 2 and so on. Okay, what is the limit of n over 2 to the power n when n approaches infinity? Well, it is infinity over infinity. So we need to use L'Hopital's. So let us go to the function. Okay, we have infinity over infinity. So let us use L'Hopital's. The derivative of x is 1. The derivative of 2x is 2x times ln 2. 1 over 2 to the power infinity is infinity. 1 over infinity is 0. So the limit of n over 2n when n approaches infinity is also 0. Okay. What about decreasing? We need to discuss the function f of x equals x over 2 to the power x. What is the derivative? I have 2 to the power x to the power 2. Derivative of x is 1 minus x times the derivative of 2x, which is 2x times ln 2. So f prime of x would be, I can take 2 to the power x as a common factor. I have 1 minus x ln 2, and I can cancel 2 to the power x with one of these two. So 1 minus x ln 2 over 2 to the power x is the derivative. Notice that 2 to the power x is always positive. And let us consider 1 minus x ln 2. What is the 0 of 1 minus x ln 2? 1 equals x ln 2. X equals 1 over ln 2. What is 1 over ln 2? 1.4 approximately. So for x greater than 1 over ln 2, which is approximately 1.4, what happens to f prime of x? Choose a number, choose 10. Okay, 1 minus 10 ln 2. Ln 2 is positive, so it would be negative. So f prime is negative, which means f is decreasing for x greater than 1 over ln 2. So Bn is decreasing for n greater than or equal to 2. So summation an from 2 to infinity is convergent by alternating series test. Hence, summation from 1 to infinity is also convergent because you are adding one term. And an is this. Okay, what is Bn here? What is the limit of Bn when n goes to infinity? Two over infinity is 0, e to the power 0 is 1. This is not equal to 0. So summation an, just a minute, let us say limit an when n goes to infinity does not exist. And by test for divergence, summation an is divergent because the limit is not 0, it is 1. Well, here, if you think about this one, what is sine n plus half pi? Replace n by 0. If you replace n by 0, n starts from 0, okay? Put in 0. You have sine pi over 2. Sine pi over 2 is 1. Put in 1. This is n, and this is sine n pi, n plus half times pi. 1 plus half, 3 over 2. 3 over 2 pi. Sine 3 over 2 pi is negative 1. Put 2. 5 pi over 2. You go back to pi over 2, which is 1. 3, negative 1. And you notice that sine n plus half pi is alternating positive, negative, positive, negative. So in fact, you can write this series as negative 1 to the power. The first is 1, so n minus 1. Or let us say n plus 1. So if n is 0, I need the first number to be positive, but I start here from 0, okay? So to the power n would be okay. Because -1 to the power 0, it would be 1 to the power 1, it would be -1, and so on. Over 1 plus square root of n. So that's the series he is talking about. And Bn here is 1 over 1 plus square root of n. And it's easy to prove that this is decreasing and the limit is 0. So by alternating series test, this series converges. Please write the steps carefully. This is the end. I'll stop here. Uh, Hopefully you understand the alternating series test.